Hello students, welcome to Learning Management System on Basics of Electrical Power System 20E11T, introduced for the first semester Diploma in Electrical and Electronics Engineering, an initiative by Department of Collegiate and Technical Education. Under Unit 4, which deals with biomass power, fuel cell and hybrid PV systems, we are going to learn in this session 30 about hybrid PV systems. PV here it means photovoltaic cells. Okay, so after completion of this session, the student must be able to understand what you mean by a hybrid PV system, what is the necessity, and then what are the different types are available and their corresponding working and application. Before we proceed with the session number 30, let us have a recap on session number 29, which we covered. So in this session number 29, we covered about a fuel cell. Then we covered about construction and working of a fuel cell and its application. Okay, so what is a fuel cell? It is a device, or you can call it as what it does. It converts, in simple terms, a chemical energy into an electrical energy. So as a construction is considered, so it contains an anode, a cathode, and an electrolyte. So the anode, it is going to be what we can say rich in electrons. The cathode, it is rich in protons. So these electrons will be what is nothing but we call it as the flow of electrons is nothing but electrical current. So at the anode, the hydrogen gets decomposed into H plus ions and electrons. So these electrons flow through the external circuitry and produces electrical current, and then they will be absorbed by the cathode. So this process is a continuous process. At the cathode, the oxygen reacts with these H plus ions and then produces water and as well as the heat. As applications are concerned, they are mainly used in consumer electronics such as mobile phones, computers, which require a lower capacity of batteries, and in some of the military applications, and in household works for backup purpose, and in automobiles. Whenever we talk about electrical vehicles, so the new trend about this automobile sector, electrical vehicles, so they wholly depend upon these fuel cells. And then in hospitals and all for the backup as a generating backup for the conventional sources where we require, say for example, if you have taken out the plant for maintenance or in case of a fault and all that, that can be supplied through these fuel cells. And in submarines and aircrafts and satellites, these fuel cells are used. Okay, in session number 30, what we are going to learn? So, we are going to learn about what I mean by the term hybrid PV systems, and then we try to learn about what are the different types of PV systems. As far as syllabus is concerned, we are going to learn in detail about two hybrid PV systems. One, PV wind hybrid system, that is a photovoltaic and the combination of photovoltaic and a wind, and then another one, PV and fuel cell combinations, and also we will see what are its applications. And then as usual at the end of the session we will have a small test, that is a multiple choice questions, so that to know whether you are in a position to understand these concepts properly or not. So what is what we are going to learn in this case? Hybrid means what? Hybrid it's a combination of power. So what we are trying to do, whatever the renewable energy sources are there, more than two renewable sources of energy, they are combined together. What purpose? To enhance the efficiency as well as to produce greater energy, we are using them. So it is difficult and uneconomical to provide all the power from only one solar system. ಈ ಒಂದೇ ಸೋಲಾರ್ ಸಿಸ್ಟಮ್ ನಿಂತ್ರ ನಾನು ಏನಾದರೂ PV ಸಿಸ್ಟಮ್ ನಿಂತ್ರ ಮಾಡಿದೆ ಅಂತಂದ್ರೆ, because as you know, the solar the solar system, or you can say availability of the sun during the day, it is available. And also in case of seasons, it depends upon the season, depends upon day and night, and then all that. So it will be very unreliable source of. Okay, so when we talk about unreliable source, it should be backed up with another source so that it can be, its efficiency can be enhanced. So that is the major thing, and it is maybe more and more economical to meet the power requirements by some other means, such as either it may be I can combine with the windmills, I can combine with the fuel cells, or a diesel or a petrol generators. So the best hybrid solar system is one ಯಾವುದನ್ನ ನಾವು ಬೆಸ್ಟ್ ಅಂತ ಕರಿತೀವಿ, in which no amount of solar power generated is wasted. ಏನೇನು ನಾವು ಇದನ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅದು ಯಾವುದನ್ನು ವೇಸ್ಟ್ ಆಗದೆ ಅಂತ ನೋಡ್ಕೊಂಡಿದ್ದಕ್ಕೆ usually we call it as 1 unit generated, or sorry, 1 unit wasted is equal to 2 units generated ಅಂತ ಹೇಳ್ತೀವಿ. ಅದಕ್ಕಾಗಿ ನಾವು ಏನಾಗ್ತದೆ, ನೀವು ಜನರೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಎಷ್ಟು ಕಷ್ಟಪಟ್ಟಿರ್ತೀರೋ ಅದನ್ನ ನಾವು ಸರಿಯಾಗಿ ಉಪಯೋಗ ಮಾಡಿಕೊಂಡಿದ್ವಿ ಅಂತಾರೆ, ಅಂತದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ, ಬೆಸ್ಟ್ ಸಿಸ್ಟಮ್ ಅಂತ ಕರಿತೀವಿ. So now what are the different types of PV systems available? ಏನೇನದವ, on what basis we are going to classify, depending upon which two or more than two combinations we are combined. Depending upon that, there are number of what we can call it as types of hybrid PV systems. One, the PV diesel hybrid system. Idu maximum it is used PV and diesel power system. ಯಾವಾಗ ಸೋಲಾರ್ ಪವರ್ ಇರ್ತದ ಅವಾಗ ನಾನು ಫೋಟೋ ವೋಲ್ಟಾಯಿಕ್ ಯಂತ್ರ ನಾನು ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಎನರ್ಜಿಯನ್ನ. ಯಾವಾಗ ನನಗೆ ಆ ಸನ್ಲೈಟ್ ಇರ್ಲಿಲ್ಲ ಅಥವಾ ಏನಾದ್ರೂ ಕ್ಲೌಡಿ ಇದಿತ್ತು ಅಂತಂದ್ರೆ, ಅವಾಗ ನನ್ನ ಸನ್ಲೈಟ್ ಇಂಟೆನ್ಸಿಟಿ ಕಡಿಮೆ ಇತ್ತು ಅಂತಂದ್ರೆ, ಐ ಕ್ಯಾನ್ ಸ್ವಿಚ್ ಓವರ್ ಟು ದ ಡೀಸೆಲ್. ಸೊ ದಿಸ್ ಈಸ್ ಒನ್ ಆಫ್ ದ ಬೆಸ್ಟ್ ಕಾಂಬಿನೇಷನ್ಸ್. ಅಂಡ್ PV and wind hybrid system, this is also good, but this both PV as well as the wind both are unreliable. ಎರಡನ್ನೂ unreliable ಇರೋದ್ರಿಂದ, so this is the drawback is that. And there is another one combination, it's also very good combination, what we call it as PV and fuel cell. So whenever the power is available from the solar system, I can use the PV cells, and whenever it is not available, I can use it from the fuel cells. It is a very reliable system. And then we can have a PV hydro, micro hydro hybrid system ಇರಬಹುದು. PO ಜಿಯೋ ಹೈಬ್ರಿಡ್ ಸಿಸ್ಟಮ್ಸ್ ಅನ್ನ ನಾವು ಯೂಸ್ ಮಾಡಬಹುದು, ಅಥವಾ PV ಬಯೋಮಾಸ್ ಹೈಬ್ರಿಡ್ ಸಿಸ್ಟಮ್ ಅನ್ನ ನಾವು ಯೂಸ್ ಮಾಡಬಹುದು. So there are n combination depending upon, or otherwise you can combine 3 to different combinations. Say PV, wind and diesel, you can have PV, wind and fuel cells you can have, so that you can enhance the reliability of your system as well as the continuous supply can be maintained. So now we'll try to, as far as our syllabus is concerned, 2 systems we have to deal with. So we'll just try to have 2 block diagrams, and then how they work we'll try to understand. First one we'll try to have PV wind hybrid system. PV andre enaithu, photovoltaic cell, it's a solar energy, and then wind energy. Both are unreliable, but still then it's a very good combination. So what we have got now? So we have got 2 combinations we have made over here. So I can make it as a 2 blocks. Okay. So one we call it as, it is converted from the PV array, and then one another load it will be supplied through the what we can call it as windmills. So now you have got a PV array. From that PV array dandra output ಏನು ಬರ್ತದ, DC ಬರ್ತದ. So DC to DC conversion ಮಾಡ್ತೀವಿ. So usually we call that as a choppers. By using that we will be converting it depending upon our requirements of the battery. ಎಷ್ಟು ಹೈ ಮಾಡಬೇಕು ಅಥವಾ ಲೋ ಮಾಡಬೇಕು ಅದನ್ನ ಮಾಡಿಕೊಂಡು ಬ್ಯಾಟ್ರಿ ಕೊಟ್ಟು ಬ್ಯಾಟ್ರಿ ಚಾರ್ಜ್ ಮಾಡ್ತೀವಿ. ಬ್ಯಾಟ್ರಿ ಚಾರ್ಜ್ ಮಾಡಿ ಅಲ್ಲಿಂದ ನಾವು ಲೋಡ್ ಅನ್ನ ಸಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಓಕೆ, ಐದರ್ ಯು ಕ್ಯಾನ್ ಡೈರೆಕ್ಟ್ಲಿ ಕನೆಕ್ಟ್ ಇಟ್ ಟು ದ ಲೋಡ್. DC ಲೋಡ್ಸ್ ಏನಾರು ಇದ್ದು ಅಂತಂದ್ರೆ, ಇಲ್ಲ ಅಂತಂದ್ರೆ ನಾನು ಏನ್ ಮಾಡ್ಬೋದು, ಇನ್ವರ್ಷನ್ ಮಾಡಿ ಇನ್ವರ್ಟರ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು AC ಲೋಡ್ಸ್ ಗೆ ನಾನು ಸಪ್ಲೈ ಮಾಡ್ಬೋದು. Okay, and then again we can use a windmill. This is another combination. Windmill ಇಂದ ಬಂದದನ್ನ AC, ಯಾಕಂದ್ರೆ ಜನರೇಟರ್ ಯಾವ್ದು ಇರ್ತದೆ ಇಲ್ಲಿ, AC ಜನರೇಟರ್ ಇರ್ತದ. AC ಇದ್ದದನ್ನ DC ಕನ್ವರ್ಟ್ ಮಾಡಿಕೊಂಡು ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಈ ಸರ್ಕ್ಯೂಟ್ಸ್ ಕೊಡ್ತಾ ಇದೀವಿ. Again that will be converted to DC to DC, and then the battery will be charged. This process will be continuous. Otherwise, if you are not having that, directly we can give an inverter. Through that inverter you can come directly give it to the AC loads. So these are the different what we can say blocks or the process in which the PV and wind hybrid system works, what we have shown over here. We just try to see how it works. So what is this most important? The variation of the wind velocity results in the large frequency changes. ಏನಾದರೂ frequency output changes ಆಗ್ತಲ್ಲ ಅಂತದನ್ನ ಇದನ್ನ ಮಾಡ್ಲಿಕ್ಕೆ. ಸೊ ಅಂತದ್ರಲ್ಲಿ ನಾವು ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, AC output ಅನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. I cannot use the AC. So what I will do here? I will first convert that into DC and then I can invert it into AC. Okay, converter. Very simple. Try to understand this. Converter ಅಂತಂದ್ರೆ ಏನ್ ಮಾಡ್ತದ? DC to AC ಕನ್ವರ್ಷನ್ ಮಾಡ್ತದ. ಇನ್ವರ್ಟರ್ ಅಂತಂದ್ರೆ ಅದರ ವಿರುದ್ಧವಾಗಿ, ಅಂದ್ರೆ DC ಸಪ್ಲೈನ ನೀವೇನು ಬ್ಯಾಟರಿ ಒಳಗೆ ಏನು ಸ್ಟೋರ್ ಮಾಡಿದಿರಲ್ಲ ಅದನ್ನ ವಾಪಸ್ ಆಗಿ AC ಗೆ ನಾವು ಸಪ್ಲೈ ಮಾಡ್ತೇವೆ. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ನಿಮ್ಗೆ ಕೊಡಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ, ಈಗ ನಾವು ಮನೆಯಲ್ಲಿ ಅಂತ ಯೂಸ್ ಮಾಡೋದು ಅಂದ್ರೆ AC ಸಿಸ್ಟಮ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ AC ಎಂತದನ್ನ ನಾನು ಈಗ ಸಪೋಸ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಯಾವುದೋ ಒಂದು ರೆಕ್ಟಿಫೈರ್ ಸರ್ಕ್ಯೂಟ್ರಿ ಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ, ಸೊ ಬ್ಯಾಟರಿ ಚಾರ್ಜ್ ಅನ್ನ ಮಾಡಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ ನೀವೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಯು ಆರ್ ಕನ್ವರ್ಟಿಂಗ್ ದಟ್ ಇಟ್ ಇಂಟು DC. How you are doing that? That process we call it as a rectification. ಅದರ ವಿರುದ್ಧವಾಗಿ ಈಗ ಆಲ್ರೆಡಿ ಬ್ಯಾಟರಿ ಒಳಗೆ ನಾನು ಎಲ್ಲ ಚಾರ್ಜ್ ಮಾಡಿ ಇಟ್ಟಿದ್ದೀನಿ, ಅದನ್ನ ನಾನು ಒಂದು ಅಪ್ಲಿಕೇಶನ್ಸ್ ಯೂಸ್ ಮಾಡಬೇಕಾಗಿದೆ, ನನಗೆ AC ಬೇಕಾಗಿದೆ ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ನಾವು ಇನ್ವರ್ಟರ್ ಸರ್ಕ್ಯೂಟ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಯು ಶುಡ್ ಏಬಲ್ ಟು ನೋ. DC to DC ಕನ್ವರ್ಟರ್ ಅಂತಂದ್ರೆ ಅದಕ್ಕೆ ಏನಂತ ಕರೀತಾರೆ, ಚಾಪರ್ ಅಂತ ಕರೀತಾರೆ. AC to AC ಕನ್ವರ್ಷನ್ ಇತ್ತು ಅಂತಂದ್ರೆ ಅದಕ್ಕೆ ಸೈಕ್ಲೋ ಕನ್ವರ್ಟರ್ ಅಂತ ಕರೀತಾರೆ. Just to remember this for your understanding of the blocks what we are going to provide it over here. Okay, so ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಅನ್ರಿಲಯಬಲ್ ಇರೋದ್ರಿಂದ ಫ್ರೀಕ್ವೆನ್ಸಿನೂ ಚೇಂಜ್ ಆಗ್ತಾ ಇರ್ತದ, ವೋಲ್ಟೇಜ್ ಫ್ಲಕ್ಚುಯೇಷನ್ ಆಗ್ತಾ ಇರ್ತದ. ಅದನ್ನ ಡೈರೆಕ್ಟ್ಲಿ ನಾನು ಸಪ್ಲೈ ಅನ್ನ AC ಲೋಡಿಂಗ್ ಕೊಡಬಹುದು. ಬಟ್ ಇಫ್ ಐ ಗಿವ್ ಇಟ್ ಟು ದಟ್, ದಿಸ್ ಫ್ಲಕ್ಚುಯೇಷನ್ cannot be what we can say avoid. Then I should have a different circuitries for that, avoiding that. ಅದನ್ನ ಮಾಡೋ ಬದಲಿ ಹೆಂಗಾರು ನನ್ನ ಕಡೆ ಇಲ್ಲೆಲ್ಲಾನು ಸರ್ಕ್ಯೂಟ್ಸ್ ಅದಾವ. So using that circuitry, what I will do, first I will convert that into DC, and then if I require an AC loads to be supplied, I will invert it and then provide it to it. Okay, and then you can have a DC output of a PV array and the rectified output of the wind generator are connected parallel to the DC link. DC link ಗೆ parallel ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಇಲ್ಲಿ ಶೋ ಮಾಡಿದೀವಲ್ಲ, DC link ಗೆ parallel ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡಿದೀವಿ. And then ಏನ್ ಮೇನ್ ಡ್ರಾಬ್ಯಾಕ್ ಅಂತಂದ್ರೆ ಇದ್ರದ್ದು ಎರಡು ವಿಂಡ್ ಜನರೇಟರ್ ಮತ್ತೆ PV ಅರೇ ಬೋತ್ ಆರ್ ವಾಟ್ ಯು ಕ್ಯಾನ್ ಸೇ ಅನ್ರಿಲಯಬಲ್. ಯಾವಾಗ ಅದು ವಿಂಡ್ ಇರ್ತದನೋ ಅಥವಾ ಎರಡು PVನೂ ಸೋಲಾರ್ ಎನರ್ಜಿನೂ ಇರದೇ ಇರಬಹುದು ಅಥವಾ ವಿಂಡ್ ಅನ್ನು ಎರಡೂ ಇಲ್ಲದೆ ಇದ್ದಾಗ ಇಟ್ ಇಸ್ ನಾಟ್ ಪಾಸಿಬಲ್ ಫಾರ್ ಮೀ ಟು ಹ್ಯಾವ್ ಅ ವಾಟ್ ಯು ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಬ್ಯಾಕಪ್. ಇದ್ರಲ್ಲಿ ಏನ್ ಬೇಕಾಗ್ತದೆ, ಎರಡೂನು ಅನ್ರಿಲಯಬಲ್ ಇರೋದ್ರಿಂದ ಲಾರ್ಜ್ ನಂಬರ್ ಆಫ್ ಬ್ಯಾಟರೀಸ್ ಆರ್ ರಿಕ್ವೈರ್ಡ್ ಆರ್ ಅ ಬ್ಯಾಂಕ್ ಆಫ್ ದ that is needed will be very high. That is what the major drawback of such a systems. Another system is what we can have here, PV and a fuel cell. Fuel cell ಅಂತಂದ್ರೆ ಏನು, chemical energy ಇರ್ತದೆ ಅದರೊಳಗೆ, already you have charged it and then stored, and then you can utilize it whenever you require, and then whenever there is a solar energy not available, I can use a fuel cells over here. So now what I have shown over here, you have got two different blocks. One is you have got a PV cell, then that will be converted, whatever the energy that is there, electrical energy that is converted into DC voltage. That DC voltage again it will be what we can call it as either stepped up or stepped down depending upon your requirements. That is DC to DC converter, and then it will be given to the what you can say next load stages here, what we have shown over here. So this is DC load into ಅಂತಂದ್ರೆ directly DC load ಕೊಡ್ತೀವಿ. ಇಲ್ಲ ಅಂತಂದ್ರೆ if its AC loads are there, I will convert that into AC by using an inverter and then supply it to AC loads. In the similar manner, from the fuel cell, fuel cell, it converts what? Chemical energy into DC electrical energy. So DC electrical energy ಅನ್ನ ನಾನು ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, DC to DC converter use ಮಾಡಿಕೊಂಡು directly I can supply it to the DC loads, or either I can give it that supply back and then invert it and then convert that can be used for the AC loads. Now in this case, you have got a controller which will be controlling these two circuitries, as well as it will be providing you what you can say, usually we call them as a firing circuits and all that will be required for conversion, as well as it will be controlling the load from where I have to draw. Either it may be from the PV cell or either it may be from the fuel cell. So depending upon our application, we will be using these two, and depending upon the availability of the solar energy over there. Okay, the reliability problem can be solved or eliminated in this system, because in this case, fuel cell already their energy is available in the form of chemical energy. So it is independent of weather. Fuel cell, whether affect agalla. There may be small variation, but it is as compared to the wind and all that, it is more reliable. So this is a reliable system. And then there will be two converters, and one feed to the PV array and the other is fed to the fuel cell. Both of these DC to DC converters are connected in parallel to the corresponding what you can say DC bus, through which I will be what you can say DC loads are connected. Okay, the DC output generated from the PV array as well as the fuel cell is converted back to AC by using an inverter. Inverter use ಮಾಡಿಕೊಂಡು ನಾನು ಕನ್ವರ್ಟ್ ಮಾಡಿಕೊಂಡು ನಾನು ಏನು ಮಾಡಬಹುದು AC ಲೋಡ್ಗೆ ಸಪ್ಲೈ ಮಾಡಬಹುದು. Okay, so this is converter is operated such that it extract maximum power. Actually ನನಗೆ ಎದ್ರ ಮೇಲೆ maximum power from the PV cells, because load cell ಅಂತಂದ್ರೆ ಏನಾಗ್ತದ ಈಗ fuel cell ಇರೋದ್ರಿಂದ ಅದನ್ನ ನಮ್ಮ chemical energy ಇರ್ತದ, ಅದನ್ನ that can be utilized whenever there is a solar cells or solar energy is not available. So maximum emphasis is given on a solar power. ಏನಿದ್ರದ main advantage? High reliability. Yak high reliability? Because even though the solar energy is not available, I can use the energy from the fuel cell, which can be utilized over here. And easy synchronization of the two DC sources as compared to synchronization of the AC sources. These are the two main importances. Then what are the applications? ನಾನು ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡಬಹುದು PV ಸಿಸ್ಟಮ್ ಅನ್ನ? ಈಗ ರಿಮೋಟ್ ಏರಿಯಾಸ್ ಇರ್ತಾವ, ಹೈಬ್ರಿಡ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ಬೇಕಾಯ್ತು. ರಿಮೋಟ್ ಏರಿಯಾಸ್ or you can say in agriculture lands ಇರಬಹುದು, ಅಥವಾ in cases of you can say only one villages are spread out, or ಒಂದೊಂದೇ ಮನಿಗಳನ್ನ ಇದ್ದು ಅಂತಂದ್ರೆ ಅಂತಲ್ಲಿ ನಾನು ಏನ್ ಮಾಡಬಹುದು, ಇಂತಹ ಸಿಸ್ಟಮ್ ಅನ್ನ ನಾನು ಯೂಸ್ ಮಾಡಬಹುದು. Okay, so it continuity of power supply that is necessary for me. In that cases, I can go for the solar as well as the combination of solar and PV cell, or combination of the biomass is available. So solar and biomass, like this I can have a different combinations. Biogas ಅಂತ ನೋಡಬಹುದು ನೀವು, ಅವರನ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾನು ಏನ್ ಮಾಡಬಹುದು, I can able to have a applications at the remote areas. ಈಗ ನೀವು ಲಾರ್ಜ್ ಎಸ್ಟೇಟ್ಸ್ ಇದ್ದು, ಫಾರ್ಮ್ ಹೌಸ್ ಇದ್ದು ಅಂತಲ್ಲಿ ನಾನು ಸಪ್ಲೈ ಮಾಡ್ಲಿಕ್ಕೆ, that is very good what we can call hybrid systems can be used. There it will be able to have all the needs that are required. Say for example, I have got a cattle sheds, or you can number of other requirements of agriculture requirements as greenhouse and all that. So that requirements can be fulfilled by using such a type of hybrid systems. In case of school and college campuses, okay, in cases of our school and college campuses, we are using in our college and all that, we are using a solar energy with the kV supply. Okay, so both will be what we can say we combined, we are utilizing it. So you can combine the renewable sources such as solar energy and wind energy, and then you can able to supply it to your school and the colleges, campuses and all that. Or in terms, you can also do it for the community housing, and in community housing also you can utilize it. So it will reduce your cost and dependency on the normal resources, whatever we are going to get. And also in case of industrial backup, okay, when you are having a diesel generator or a electricity board from where you have taken it and all, but still then if there is any failure in that, that can be what we can call backup can be had from such a type of systems. And also in case of street light, okay, this is one of the best examples as you might have seen in your street lights and all that. Both can be used, solar as well as the wind, solar as a fuel cell. Like this, you can have a different combinations over here. Okay, what we have learned in this session, ಏನೇನ್ ಕಲ್ತೀವಿ ನಾವು? ಮೊದಲು ಹೈಬ್ರಿಡ್ PV ಸಿಸ್ಟಮ್ ಅಂದ್ರೆ ಏನಂತ ಕಲ್ತೀವಿ. ಹೈಬ್ರಿಡ್ ಅಂದ್ರೆ ಏನು? ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಮೋರ್ ದ್ಯಾನ್ ಒನ್ ಟೂ ಸಿಸ್ಟಮ್ಸ್ ಓವರ್ ಹಿಯರ್. PV ಸಿಸ್ಟಮ್ಸ್ ಅನ್ನ PV ಸಿಸ್ಟಮ್ ಜೊತೆಗೆ ಯಾವ್ದಾದ್ರು ಒಂದು, PV ಅಂದ್ರೆ ಫೋಟೋವೋಲ್ಟೈಕ್ ಸೆಲ್ ಸಿಸ್ಟಮ್ ಅನ್ನ ಜೊತೆಗೆ ಯಾವ್ದಾದ್ರು ಒಂದನ್ನ, ಬಯೋಮಾಸ್ ಇರ್ಬೋದು ಅಥವಾ ವಿಂಡ್ ಎನರ್ಜಿ ಇರ್ಬೋದು, ಅವನನ್ನ ನಾವು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಸಪ್ಲೈ ಮಾಡಿದ್ದಕ್ಕೆ ನಾವ್ ಏನಂತ ಕರಿತೀವಿ. ಓಕೆ, ಸೊ ಮತ್ತೊಂದು ಮೇನ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಅಂದ್ರೆ PV ಮತ್ತು ಎರಡು ನಾವು ಹೈಬ್ರಿಡ್ ಸಿಸ್ಟಮ್ ಅನ್ನ ನಾವು ಕಲ್ತಿದೀವಿ. ಯಾವ್ಯಾವು? PV ಮತ್ತು ವಿಂಡ್ ಮತ್ತು PV ಮತ್ತು ಫ್ಯೂಲ್ ಸೆಲ್. ಫ್ಯೂಲ್ ಸೆಲ್ ಅಂದ್ರೆ ಏನು? ಹೈ ರಿಲಯಬಿಲಿಟಿ ಇತ್ತು, ಮತ್ತೆ ಸಿಂಕ್ರೊನೈಸೇಷನ್ ಆಫ್ DC to DC ಇಟ್ ಇಸ್ ವೆರಿ ಈಸಿಯರ್. What is the conclusion what we can have? So what we are using, they provide, the hybrid PV system provide an efficient and reliable energy source, which can be, what we can say, we can trust and then use it on it. So these are the references which were referred for preparing this content, and some of the pictures we have taken it from that e-resources, whatever we have shown over here. So at the end of the class, just we'll have a multiple choice questions. So what it shows, first question what it says, the main source of wind is, the main source of wind? Universe, uneven land? No. Changes in the season? No. Vegetation irbodu? Illa. The main source of all the sources? It's the sun is the major source. The major disadvantage of PV wind hybrid system is what? Major disadvantage of PV ಮತ್ತು wind ಎರಡು unreliable ಅದಾವ. Both our sources are non-reliable. Okay, that's why we call them as unreliable sources. Major disadvantage. Advantage ಇರ್ತದ. ಎರಡನೇದು ಏನದ advantage the wind and solar energy available free of cost ಅದ. Low initial cost wrong ಆಗ್ತತಿ. Okay, so the major disadvantage is major I am talking about. Okay, so that is what we can call both are non-reliable. The main advantage of PV fuel cell hybrid system is what? PV fuel cell. Fuel cell ಮತ್ತು PV cell ಏನಿರ್ತಾವ? They are efficient, reliable ಅನ್ನೋದವ, low initial cost ಅನ್ನೋ ಮೂರು ಕೇಳಿದಾರೆ. ಎರಡನ್ನ ನಾವು ಅಥವಾ A and B ಅಂತ ಕೇಳಿದಾರೆ. Yes, they are more reliable and also they are efficient. Both A and B are the correct answer. Low initial cost ಆಗಂಗಿಲ್ಲ because PV systems cost more and the fuel cells also will be costing more. PV wind hybrid system suits for the locations where sunlight and wind have a seasonal shifts. Yes, so that is true. Okay, so this is true because ನಿಮಗೆಲ್ಲಾದ್ರೂ seasonal shift ಆಗ್ತಾ ಇದ್ದು ಅಂತಂದ್ರೆ ಯಾವಾಗ ಸೂರ್ಯ ಚೆನ್ನಾಗಿ ಸೂರ್ಯನ ಬೆಳಕಿರ್ತದ ಅವಾಗ PV cell ಅನ್ನು ಯೂಸ್ ಮಾಡಬಹುದು. ವಿಂಡ್ ಯಾವಾಗ ಚೆನ್ನಾಗಿರ್ತದ ಅವಾಗ ವಿಂಡ್ ಎನರ್ಜಿಯನ್ನ ನಾವು ಯೂಸ್ ಮಾಡಬಹುದು. The DC to DC converter is used to what we can call charge the batteries, supply the DC loads, monitor the output voltage. All the above ಎಲ್ಲಾನು ನಾವು ಏನ್ ಮಾಡಬಹುದು ಯೂಸ್ ಮಾಡಬಹುದು. ಚಾರ್ಜ್ ಬ್ಯಾಟರಿ ಚಾರ್ಜ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಸಪ್ಲೈ DC ಲೋಡ್ಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಸಪ್ಲೈನು ಮಾಡಬಹುದು. ಮಾನಿಟರ್ ದ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್, ಯಾಕಂತಂದ್ರೆ ಇಲ್ಲಿ ಅನ್ಇವನ್ ವೋಲ್ಟೇಜಸ್ ಬರ್ತಾವೆ ಅದ್ರೊಳಗ ವಿಂಡ್ ಎನರ್ಜಿ ಒಳಗ. ಅದನ್ನ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಕನ್ವರ್ಷನ್ ಮಾಡ್ಕೊಂಡು, ಅದ್ ಮೊದಲ ಇನ್ವರ್ಷನ್ ಮಾಡಿ ಆಮೇಲೆ ಕನ್ವರ್ಷನ್ಸ್ ಮಾಡ್ಕೊಂಡು ಅನ್ಇವನ್ ಇದ್ದದನ್ನ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ ಒಂದೇ ಲೆವೆಲ್ಗೆ ಇದನ್ನ ಮಾಡ್ಕೊಂಡಿರ್ತೀವಿ. The PV and a fuel cell hybrid system is affected by seasonal changes. Partially affect ಆಗ್ತದೆ, ಯಾಕಂದ್ರೆ ಇದ್ರೊಳಗೆ ಏನದ PV cell and affect ಆಗ್ತದೆ, fuel cell not affected. So I can say it is partially affected. The PV fuel cell hybrid system is used in applications where continuous power is required. Yes, true. Okay, this is true because PV cell ನನಗೆ ಏನಾದರೂ ಸಪ್ಲೈ ಕೊಡ್ತಾ ಇಲ್ಲ ಅಂತಂದ್ರೆ I can use a fuel cell and then I can continue with my supply. The AC output of a wind generator is first converted into DC and using inverter again it is converted back into AC. ಯಾಕೆ ಹಿಂಗ್ ಮಾಡ್ತೀವಿ? ಯಾಕಂತಂದ್ರೆ the variation of the wind velocity results in large changes in the frequency and the output voltage. Or second one ಏನದ, the variation of the wind velocity does not affect the wind is season dependent, none of the above. The answer is what? Because we are using it because the frequency and the voltage changes are more. Okay, that's the A is the answer. The world faces an energy crisis because ಎದಕ್ಕೆ ನನ್ನ ಎನರ್ಜಿ ಕ್ರೈಸಿಸ್ ಅದಾವ? ವರ್ಲ್ಡ್ ಡಿಮಾಂಡ್ ಆಫ್ ಎನರ್ಜಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ಲಿಕ್ಕತ್ತದ. ವರ್ಲ್ಡ್ ಆಯಿಲ್ ಪ್ರೊಡಕ್ಷನ್ ವಿಲ್ ಪೀಕ್ ಅಂಡ್ ಬಿಗಿನ್ ಟು ಡಿಕ್ಲೈನ್. ಶಾರ್ಟೇಜಸ್ ಆಫ್ ಆಲ್ ದ ರಿಸಲ್ಟಿಂಗ್ ಎಸ್ಕಲೇಷನ್ ಪ್ರೈಸಸ್ ಕ್ಯಾನ್ ಶಾಕ್ ದ ಎಕನಾಮಿಕ್ ಅಂಡ್ ಪೊಲಿಟಿಕಲ್ ಆರ್ಡರ್. ಹೌದಾ, ಎಲ್ಲಾನು ಬರ್ತಾ ಇದಾವ. ಆಲ್ ದಿಸ್ ಆರ್ ದ ಕಾಸಿಂಗ್ ಫಾರ್ ಅಸ್ ಫಾರ್ ಅ ಎನರ್ಜಿ ಕ್ರೈಸಿಸ್. ಔಟ್ಪುಟ್ ಆಫ್ ದ ಸೋಲಾರ್ ಸೆಲ್ ಎಷ್ಟು ಇರ್ತದ? ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಇಟ್ ವಿಲ್ ಬಿ ಅರೌಂಡ್ 1 watt. Okay, of the order of 1 watt irtava. Okay, so I wholeheartedly thank the members who have been mentioned in this, who have directly or indirectly helped me to develop this content. Before we conclude our session, if you have got any suggestions about the content or the tools that what we have used and the format in which I have presented. Please suggest and then write to lms.dtek@gmail.com. Your suggestions will be taken positively to improve our next endeavors. I thank you one and all. Happy learning.